All right, math fans, we're going to be talking today about some basic probability. We're going to do an introduction to that. Before we start, let me give you your joke of the day. How did the barber win the race? The answer, he knew a shortcut. Okay, so we're going to start with kind of a classic example, which is you roll a six-sided die. So rolling dice, we roll one of them. What is the probability that the outcome is? Now, first of all, when we talk about probability, let's define what that is. A lot of times we will use the letter P, the capital letter P, to represent the word probability. But the way we calculate it, if we are trying to calculate the probability of an event happening, what we calculate is the number, that's my symbol for number, the number of ways to be successful. And success means whatever it is we're trying to measure. Number of ways to be successful divided by the total number of outcomes or events. In this case, we're going to roll a die. And for the first one in part A, what's the probability that we roll a 3? So the success in this case would be that we get the number 3. One way to think about this, okay, we'll start by visualizing, is we'll look at what's called the sample space. And the idea is, what are the total outcomes that we can have? So if you roll a die that has 6 sides, well, you could get a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 possible outcomes. So the total number of outcomes is going to be 6. In part A, a success means that this occurs, that we get that value. In this case, well, we can get that. How many ways, number of ways to be successful? Well, there's one way. So you have to roll the number 3. So this answer would be 1 out of 6, the total number of outcomes. Okay, now let me get my calculator. Because when we talk about probability, you can write it as a simplified fraction. In this case, that's probably going to be easiest, but we can also look at it if we take 1 divided by 6. We can look at it as a decimal, which is 0.16 repeating. If you're thinking of a percentage, that would be 16.6% or 16.7%. So if I round it here, I'm going to round this to 2 places. I will say 0.17. Okay, and you can think, we like to think in terms of percents. Now, normally I'm either going to write it as a fraction or a decimal. I'm not going to write probability as a percentage, and I'll explain why in a moment here. So the probability that we get a 3 is 1 out of 6. Okay, one way to get the 3, 6 ways, 6 total outcomes. How about the probability that it's not a 3? So we roll the die and we get something other than a 3. Well, how many ways can we not get a 3? We could get a 1, a 2, a 4, a 5, or a 6. So there's actually 5 ways that we could get that out of how many total outcomes? Well, there's 6 outcomes when you roll a die. And 5 out of 6 as a decimal is 0.83, repeating. Okay, and I'll round it to 0.83. Probability, the reason why I don't normally use a percentage is probability has to be between 0 and 1, okay? I could actually say 0 is less than or equal to the probability is less than or equal to 1. 1 means there's a 100% chance that it happens. 0 means there is no chance. There's a 0% chance it happens, or it's impossible. Okay, so that's why when I write 17%, that's not a number between 0 and 1, so we usually keep it as a fraction or a decimal. What's the probability, part C, that we get a 4 or a 5? So now we could have one or the other. Both of those would be considered success. Well, in my sample set, I have 2 ways to do that. I can roll a 4 or a 5 out of 6. Now, as a fraction, we simplify that to 1 out of 3. Don't leave it as 2 over 6. 1 out of 3, or 0.3 0.33. What's the probability that we get an even number? Now this is where I start kind of writing down, okay, what's a success? Even would be 2, 4, 6. There are 3 ways to be successful out of 6, which reduces to 1/2 or 0.5. The probability that our value is less than 5. Okay, now less than means it has to be smaller. So again, let's think. What numbers on a die are less than 5? Well, 1, 2, 3, 4. 5 is not less than itself. Okay, so I don't include that, and then 6 is too big. So there are 4 ways out of 6 for us to be successful. That reduces to 2/3, which is 0.67. This is also where knowing some basic decimals can be very helpful to you. 2/3, 1/3, those come up a lot. 0.6 repeating, so 0.67. What is the probability that our die is showing at least a 5? Now that means 5 or more, and in this case, that could be a 5 or a 6. Well, 2 ways out of 6, which is 1/3, 0.33 again. Part G, what's the probability that our die is showing 3 and an even number? Now this is something we have to be careful about. If we're going to say and, it means that both of these have to happen at the same time. The problem is 3 is not an even number. Evens are 2, 4, 6. 3 is an odd number. So you have to ask, is it possible for both of these to happen at the same time? And the answer to that is no. So the probability of this is 0 because it can't happen. If I get a 3, I can't also get an even number. If I get an even number, it can't be a 3. If you want to think of this visually, we can think of it as like a Venn diagram where here's 3, here's the even numbers, which are like 2, 4, 6. They have no overlap. It can't, if I'm in this circle, I can't be in this circle. It's impossible. So the probability of both of them happening at the same time is 0. And it's because of this word and. If I change it just a little bit to where the word is now or, the probability that I get a 3 or an even number. Now, or means that it could be this, and that would be a success, or it could be this, and that would be a success. So how many ways could I be successful? Well, there's 4. 4 values will make this work out of 6, which is 2/3, or 0.67. The word and means they both have to happen at the same time. The word or means either this one or these can work, and we count them. All right, the last one here, what's the probability that the die is even or odd? Well, here's or. Evens are 2, 4, 6. Odds are 1, 3, 5. In this case, because it's an or problem, we can count all of these as successes. Well, 1, 2, 3, 4. There are 6 values that would be a success out of 6, and that is equal to 1. So in other words, there's a 100% chance that if I roll a die, I will get an even or an odd number. If I say the probability of even and odd, however, that means that that die has to show them both at the same time. That's impossible because the number's either even or it's odd, but it can't be both. Okay, so if you see the difference between the or and the and, then you have a pretty good understanding. And that's the end of part 1.